So, how is life on Earth dependent on the intermolecular interactions of water? Water is an important compound that we depend on. Reasons why water is important includes that it regulates the Earth's temperature, can dissolve many substances, is important in biochemical reactions, having life-sustaining properties, has a wide range of temperatures, brings nutrients to the plants, and the boiling and freezing point of water makes the molecules to be slow to boil or freeze. This is important because if water was very easy to freeze or boil, drastic changes in the environment will cause the organisms in the ocean or lakes to die. The reason why water has these properties is because of molecular interactions. We know that water has 3 atoms, 1 oxygen, and 2 hydrogens. But the oxygen also has 2 lone pairs. The 2 lone pairs are electrons, which push the hydrogen down into an upside-down V shape. Using the steric number, we can then find out the name of the shape that the molecule is in. So the steric number of water is 4. So the shape is either a bent / angular, or if you're considering the lone pairs, it would be a tetrahedral. The reason why oxygen has 2 lone pairs is because of the octet rule. We know that oxygen and hydrogen have different electronegativity, and oxygen having the greater electronegativity, meaning it is attracting the electrons from the hydrogens. This is what forms the covalent bond between the oxygen and hydrogen using dipoles. Because the oxygen is attracting the electrons, it became partially negative, while the hydrogen becomes partially positive. Because of the difference in electron density, we know that water is a polar covalent molecule. When there are multiple water molecules present, the partially positive hydrogen will bond with the partially negative oxygen, which creates a dipole-dipole bond. But since it is involving a hydrogen and oxygen, it is considered a hydrogen bond. Now, another bond that will occur is the induced dipole bond. The induced dipole bond happens because water is a polar compound. And when polar compounds go near each other, it rearranges the electron within the compound, making one side partially negative and one side partially positive. When that happens, there will be a slight bond between the partially negative and partially positive side in the middle, and this is called the London dispersion force. Or in this case, the induced dipole bond. All of these contribute to the properties of water, which is the 100 degrees Celsius boiling point, 0 degrees Celsius melting point, and 997 kilograms per meter cubed density. These life-sustaining properties are because of the intermolecular bonding that is taking place.